Utah has a spectacular Mesozoic rock record. It has an interesting range of colors and textures, fossils, and still geologic mysteries to be found. That's why today I'm here in Utah, so we can take a look at Utah's Mesozoic rock record, or stratigraphy. Specifically, we're going to be looking at the Cretaceous period in northeast Utah and topography, guys. So now we have arrived. Alright guys, classic red bed. And it's characterized by these episodic inundations of the sea onto the continent. It's also characterized by orogenic events that built mountains and spewed volcanic ash onto the landscape, as well as the rise of placental mammals and flowering plants, and also the dinosaurs, of course. Northern Utah in the Cretaceous was dominated by marine and marginal marine environments, leaving behind an outstanding sedimentary record that includes marine shales and limestones, as well as terrestrial floodplain deposits, including sandstones, siltstones, and conglomerates. There was tremendous crustal loading along the thrust belt, and a huge interior basin developed, where, when the water inundated the land, it created massive interior seaways like the Mowry Sea and the greater Western Interior Seaway. It was preceded by perhaps the more famous Jurassic Period. If you'd like to learn more about the Jurassic Period, check out some of the videos I did on the Jurassic, including Utah's stratigraphy. Now, the Jurassic Period was characterized by, of course, the dinosaurs walking across floodplain environments along Utah's coastal and terrestrial landscapes. And it was the beginning of flying reptiles, the early starts of mammals, and it's represented a lot by these colorful mudstone layers that also include some ash and sandstones as well. But we are leaving the Jurassic behind around 145 million years ago to head into the Cretaceous. Now, after leaving the Jurassic, the first of Cretaceous formations that we come across is the Cedar Mountain Formation, and you can see it in the cliffs behind me. The Cedar Mountain Formation consists of those colorful shales as well as some sandstone. It's quite similar to the Morrison Formation. In fact, it can even be confused with the Morrison Formation, and it erodes with the underlying Morrison, which kind of obscures the boundary between the two. But in general, the Cedar Mountain can look a little more drab, the Morrison can look a little more colorful. Now, the formation is further broken down into some recognized members, such as the Buckhorn Conglomerate, which represents a fluvial river channel type of environment, similar to some of the ones we find in the Morrison. And also the yellow cat and poison strip members, which are associated with uranium deposits, and a few others. But what's really exciting about the Cedar Mountain Formation are the dinosaur fossils that have been found. Now, everyone probably thinks of the Morrison Formation and the Jurassic as a great source of dinosaur finds, and it was. But in about the 90s, geologists and paleontologists started finding dinosaur fossils in the Cedar Mountain Formation and quickly discovered that it was a very important formation when it comes to dinosaurs. In fact, they found a sauropod skull. They also found a lot of other dinosaur fossils, some of which were a collection of a lot of different kinds of dinosaurs in an area called Tony's Bone Bed. Now, in addition to those dinosaurs, paleontologists have also found other fossils, such as those from mammals and birds, amphibians, reptiles, and microfossils, other organisms that lived alongside the dinosaurs that are just as important. Then, the seas began to change again. Then, about 101 million years ago, the Dakota Sandstone was deposited. This is a light gray to yellow, cross-bedded sandstone and conglomerate unit. The harder resistant sandstones of the Dakota typically sit atop softer units, such as shales, a process leading to huge blocks tumbling down. Another characteristic of the Dakota Sandstone are those hogbacks, which are steeply dipping or nearly vertically tilted strata. We can observe some impressive outcrops around the San Rafael Swell, a large anticline in eastern Utah. The Dakota represents a transgressive shallow marine phase, and the sands source primarily from fluvial and estuarian depositional environments. Because of this paleogeography, many authors have argued that the western and eastern portions of the Dakota Formation should be treated as separate units because they were literally separated by an interior sea.
Hence, the name is considered antiquated, and the western part is often referred to now as the Naturita Formation. It's actually quite an extensive formation across North America, and it serves as a valuable reservoir of both water, the Dakota Aquifer, and hydrocarbons associated with lenses of oil and gas. Due to the tidal and marine origins of the sandstones, we can find fossils such as petrified wood and invertebrate shell fragments in the Dakota Sandstone or Naturita Formation. And as the seas continued their march, shales became deposited on top of the Dakota Sandstone.
In strike valleys, sandwiched between two sandstone phases of the Cretaceous system, that is, the Frontier Sandstone and the Dakota Sandstone, the Mowry Shale represents a time of transgression when the seaway inundated the continent, that is, the Mowry Sea. Fish scales and otherwise disarticulated fish remains are fairly common. Check out the fish scale I just found here. Ammonites were found in flat impressions. I have an ammonite impression right here that's from the Mowry Shale. Mowry consists of gray, fissile, silicious shales, like this stuff eroding out of the hill here behind me. Mowry also plays a very important role in oil and gas resources in the West. Mowry is part of the Mancus-Mowry Total Petroleum System, and that's all part of the greater Uinta-Piance Basin.
And once again, the depositional environments shifted.
Now, after the Mowry Sea receded, we're left with a different formation, and that's the Frontier Sandstone. The Frontier Formation consists of two main units, the upper unit, which is primarily the sandstone unit, and a lower unit, which is a little bit more like shale. And one of the coolest things about the Frontier Sandstone is that it contains huge cannonball-sized concretions. Then around 94 to 80 million years ago, the Mancus Shale was deposited along the western edge of the Interior Seaway. Now, I like to call it the Veil of Shale because of the way that the shales erode into these pretty obvious hills of kind of a drab gray and yellowish tone. Now, despite it being primarily made up of those shales and those marine muds, it also consists of some sandstones that come from barrier bars and also stream deposits, and it's also made up of some coal beds that come from the lagoonal environments as well, and it includes some bentonitic clays that come from volcanic ash.
And the Mancus, along with adjacent formations, is a source of hydrocarbon resources of the American West.
Now, the Mancus Shale is a very thick unit. It can be over 5,000 feet or several thousand meters in some areas. It can also be a very fossiliferous unit in some regions. It includes marine-related fossils such as ammonites, brachiopods, bryozoans, and inoceromus, which are like oysters. And you can find fossils like this around its type section in Mancos, Colorado. The transgression and regression cycles that are represented in the Cretaceous really helped with oil and gas formation. The formations, the shales like Mancus and Mowry, represent seals, while the sandstone formations like the Frontier and Dakota Sandstones serve as the reservoirs. And in the MesaVerde Group, we see lots of these sedimentary units from shales on to sandstones, and so we have a lot of seals and reservoirs. Altogether, that's why these units represent such a big part of oil and gas resources in the West. Like these rocks back behind me, that's the MesaVerde Group, and this is a great example of that regression-transgression sequence. Now, if you look at those rocks, you can see that yellowish-colored cliff-forming sandstone interrupted then by those gray, softer shales. Those are the sequences of the continental beach near-shore sandstones grading into those soft, silty shales. And this sequence goes on and on and on in many localities. Now, the MesaVerde Group is found all over the place. You can find it in New Mexico, Colorado, Utah, Wyoming, but it's named after the type section found in southwest Colorado. There, where you find the MesaVerde Group, it's a nice one regression sequence. And the formations that are the Point Lookout Sandstone, the Menifee Formation, and the Cliff House Sandstone. However, if you were to go and look for the MesaVerde Group outside of that type section, say in Utah, you'll actually find even more formations representing more regression transgression cycles. All right, and so ends our tour of the Cretaceous formations you can find in northeast Utah. Now, if you head a little more north or west, you can also run into a few other late Cretaceous formations. We talked primarily about those that you'll find in the more extreme northeast corner of Utah, such as around Dinosaur National Monument. But there are a few others as well, such as the Price River Formation and the North Horn Formation. But as we head into the late Cretaceous, we essentially as we get to the end of the Cretaceous, we're getting to the end of the Mesozoic era. And that means heading towards a massive extinction event, the KPG boundary, or it used to be called the KT boundary. It's the boundary between the Cretaceous and the Paleogene, which goes right into the Cenozoic. And as we know, that marked the end of some of these dinosaurs we've talked about here, and it's setting the stage for mammals, the age of mammals in the Cenozoic. So we'll be taking a look more at the Cenozoic, and we'll be taking a look at some other details about the Mesozoic here as well. So if you haven't already subscribed to Let's Go Geo, go ahead and join me on all of these wonderful adventures in geology, and I'll see you there.